Welcome back to Electronics Simplified, and today we are having an exciting project that will be interfacing the DS1302 real-time clock with a ESP32. And that's not all. We'll be displaying the real-time on an LCD and also on a web server. So why is this really an important project? Well, real-time clocks are the heartbeat to many projects. They ensure that the timekeeping is accurate. By interfacing the DS1302 with the ESP32, we can incorporate precise time data into various applications and displaying it on both on LCD and a web server. So, without wasting any more time, let's gather the components that we need. We will be needing the DS1302 real-time clock module. Now this clock module is a real-time keeper. It can store time in the format of hours, minutes, seconds, and it can also store the current date. So how does it really store the date? It stores the date from the compiled form from where the code is being uploaded. It is called as the compile date. Now that compile date is stored into the DS1302 chip here, that is the integrated circuit placed on it, and that is later the clock keeps on working even though the system turns off. So whenever the system accidentally turns off due to a power failure, this particular module keeps running because of the battery that is placed on it, that is the CR2032. This lithium cell keeps this particular module powered and does not allow any sort of loss of time in the project. This module has different pins. As you can see, it has a VCC, ground, clock, data and reset. So basically VCC and ground is something that most of the modules have. Clock is used to store the is used to so that it can match the clock timings of the data frames, and the data is basically to receive the compiled timings from the given from wherever the program is being uploaded. It could be a computer, it could be a bootloader. And reset is to get rid of the timings that are actually stored on it. So next we will be needing the ESP32. For more information about this module, you could look into look into my channel and find a video about the ESP32. The link to that will be given in the description. And to show the real-time clock output, we'll be using a 16:2 LCD module along with the I2C mounted behind it. Now I'm using this so that I can simplify the connections, and we'll be needing a few jumper cables, female to female jumper cables, and a micro USB to upload the code. So now let's have a look at the circuit diagram. So this is the circuit diagram, and as you can see that most of the connections are to be done only on one side of the ESP32. If you do not have two ground pins on your ESP32, you might have to use a breadboard to get these connections done. I will be using just jumper cables. So the circuit diagram is provided in the description, and in case we want to follow me on how to do the connections, I'm going to start connecting the real-time clock module. Right, so now I'm going to connect the VCC the VCC to the 3 volts of my ESP32, and then the ground pin, that is blue, go to ground on my ESP32. So I'll quickly connect it, and then the next pin is clock. The clock pin goes to pin number D5, so I'll connect it to D5. And then the next pin is data pin, it goes to pin number D4. And then the last one is reset, so I'm going to connect that to pin number 2. So all the connections are done. So pin number 5, 4 and 2 are connected to the RTC module, and after that we'll be connecting the LCD. So again the same process, the ground and the VCC will go to ground and V in. So ground and V in. I'm going to connect them simultaneously. Yellow is ground, orange is VCC, red is serial data is connected to pin number 21. So 21 is here, and serial clock is connected to pin number 22. Okay, now I have not decided the pin numbers randomly. Now you could actually look at the pin map diagram of the ESP32, and you'll realize that serial data and serial clock, these pins are actually defined onto particular pins on your ESP32 model. So I'm using the dev kit version 1 module. If you're using another module, you might have to change your pins in case if it's not working. If you do not want to understand the code, or if you just want to upload the code and check your circuitry whether it's working fine, then you could actually download the code from the description. But before that, you might have to install a few libraries. So I'll just tell you, you might have to include a few libraries like the asynchronous web server library, then the RTC library, and the liquid crystal I2C library. All these libraries will be provided in the description, and you can download them, install them in the same way as you have done before. In case you do not know how to do it, you could refer to my previous videos on how to install Arduino libraries. So here you could type RTC and hit search. So when you start searching for RTC, you might or you can type, let me scroll down and actually search RTC by Raccoona. Okay, so this might take a while. Let's actually just type RTC and search for it. I already have it installed on my computer. You might need to search for the one that I am actually referring and the tutorial is made for. So in case if you do not want to search for the library in this manner, then it would be better if you could download it from the links that I provide in the description. Yeah, okay. So it's not Racuna, it's Makuna. Okay, sorry about that. And you could just click on install. It's already installed, but right now I'm just updating it. There was another latest compilation of the library. So there you go. And this is it. Alright, so now this is installed, and you might also need the asynchronous web server, because we'll be also be including the asynchronous web server. So the link to that is in the description. Now I'm going to type the code. So let's start. The first library that we would need is definitely the Wi-Fi, and okay, include wi-fi.h, and then the next one would be the ESP async web server, and then the third one that we would need would be something called as 3-wire. Now 3-wire is the RTC library, and we would need another one. It's just a header file, sorry. And we'll also be needing the RTC DS1302, because that's the model that we are using. There are various other DS13 series available in the market, so you need to use the right one. Then the liquid crystal, and since we are using the I2C, it's I2C.h. Now as usual, you might want to get this done quickly, the SSID. So if anyone of you wants to understand this part of the code, you could refer to on how to connect the ESP32 to the Wi-Fi, and go through that series so you can understand the ESP32 even more better. So here the LCD column, we have 16 for LCD, and the number of rows, there are just 2 rows for display. So let's initialize all the communication. Initialize communication for the DS1302, and we need to write 3-wire, and let's say my wire. So my wires are that is actually 4, 5 and 2. If you can see, 4, 5 and 2, 4, which is my data, is actually data, 5 is the clock, and 2 is the reset. So it's in this order. After that, not forgetting the semicolon there, and then we need the RTC instance with the model specified DS1302, and we'll leave it to 3-wire. Okay, the wrong braces, because this is a header DC with my wire. I think this is all that we need to do to set up the communication for the DS1302. Now there are some complex part of C programming here, C++ programming. In case if you want to brush up, you could watch some video on YouTube and understand these concepts. I'm going to initialize the LCD now. So for that we need to get the object liquid crystal underscore I squared C, and we need to write the address. It's the address finder. If you do not know how to find the address of your liquid crystal display, then you could refer to another video that I will also give another code in the description called as address finder. You could upload that and check for your address on which your liquid crystal display is connected, and you could change the address later. The asynchronous web server, so ASYNC web server, and let's call it as server and define the port as 80. So asynchronous web server on port number 80, that's it. I'm just thinking whether we have anything left to be done. In case we have anything else to initialize, we'll come back later. Now here, like I always say, the best practice is to get the serial monitor in the picture. So serial.begin 115.2.0.0, and let's get the Wi-Fi connected. Alright, so now the connection is done. Now we need to initialize our LCD. So it's just going to be lcd.init, and in case if you want the backlit, then you can add lcd.backlit, and that will turn on your backlit. And now we need the compile date and time. So now we are talking about the DS1302 DS1302. Okay, so let's print the compiled time, and that will be serial dot print double underscore date. Okay, and serial dot print double underscore time. All right, so this is basically these are basically the environment variables that we are getting in the date and time. And now we'll initialize our RTC module. So RTC dot begin. Here the begin is capital because the developers have defined the initialization with a capital B. Okay, now I know that it's funny. There is no standard format of defining variables, I mean functions, although there is a set, but who cares? All right, so now let's get the compilation data, I mean compilation time, and print it. So let's say RTC date time compiled. Okay, compiled, which is equal to RTC date time, and here we take the compile date and time. All right, so now we need to get a function to print the date and time on the LCD. First we'll only look at the LCD, and then we will get another one for the web server. All right, so let's look at this. Let's now let's get a small function called as, let's call it print date time. Now what is this function really going to do? Now this print date and print date time, this function print, let me actually write it on print date time. This function is actually going to be solely be responsible for getting the pointer, the string, in the right format, the month, day, year, minute, second. So all this data can be got out of the module even separately, but we are going to get it nicely in a nice string format, like I had shown you before, like the month, the day, then the year. Like I live in India, here the preference is the day, then the month, then the year, and so on. So you could change it accordingly. So let's get a date string, which is going to be an array. I'm going to call it as date string, and I'll predefine it to be 20, the length to be as 20, because I do not want it to exceed that format of the date and time. So here let's get it down so that you can see. Printf, and this is date string comma count of. Okay, count of basically is a function that is that actually counts the length of the array. So PSTR. Now what exactly is SN It's very similar to the standard print function, but with added capability of handling strings stored in program space. And PSTR is the one, it is that thing which defines the string constant in program space. Okay, so do not worry about what exactly are these terms for. Alright, so let's write the string now. So if you're very familiar with C programming, you will not worry about what I'm doing right now. Okay, so to slash, because the year has to be 4 digits long, so 04, then the R, after the R we are going to have a semicolon, and then the semicolon. Alright, so R minutes and seconds. So this is it. That's the right format, and not a semicolon but a comma. So now here we need to define, I'm going to say now dot a month, because I could write here day. Okay, then put a comma and then write now comma month. So it's better if we put this on a new line so that it becomes easier to understand. Now dot year comma now dot r comma now dot minute comma now dot second. All right, so after the second, no need of a comma because we have no other data left, and then put a semicolon and close it. So here we have basically got the date string, and this bracket here is extra. All right, so now this is basically the print date time. Okay, now here okay, so I've written dt. Okay, let me go and check up here that we have defined all of, yeah. So now print date time. Okay, here we need to define a few things, like I'm just going to say, okay, now we could do this in another method. That is what I was just thinking about. So might make a few changes about passing parameters of the constant RTC date time and address dt. So let's change this to dt. Okay, I'll also be using now later in when it comes to the web server. So nothing really changes. That's it, and we'll just serial print this on a new line and basically print the entire date string. After that, we need to push it onto the LCD. Okay, so for the LCD, we'll have to, in the first case, you'll have to clear the LCD. So say clear, and then set the cursor. So set cursor to the position 0, 0, and then lcd.print. Now you can print whatever you want here if you want to test it, but we are more into the date string, so let's print it down there. Now that's all. This is all that is needed to get it printed on the LCD. So if we run this code and the white loop, just need to call the date and time. So RTC date time now equal to RTC dot get date time, and then print the now time, that is print date time now, and then see, let's serial print a new line, an empty line, so that since this is an entire function, I don't want to ruin it by adding another new line character there. So this is the easier way how to do it, and then that's all. So now there are certain situations where the date time from the RTC is not valid, or sometimes it's disconnected, or it forgets to, there are different things where it's not sure about the timing. Like there's a big difference between the compiled time and what time is actually there on it. So there are various errors that it could throw. So we are going to take care of that as well. So let's write the first case. Check if the date time from RTC is not valid. Okay, so if now is valid, then serial dot print, we can't do anything about this, so we are going to say lost confidence. And basically here you might have to actually uh, check for the battery, or you could check if it has enough power. So these are the two things that you can think of. I mean, I can think of. And another thing is you could disconnect and remove the battery and reconnect it. All right, so then that's one part. The next thing is, like, after how frequently do you really want to check or update your time? So I'm going to add a delay here of just 1 second. All right, so I forgot one thing, that is the count of and size of definition to calculate it. Okay, so I'll just define it after this function here. I'll just type here macro to calculate the size of an array, and right here hash define count of a size of a divided by size of a 0. That's the first. Okay, so I mean this does not need a semicolon since this is a definition. And then print date time. Okay, so this part of this function is done. Now let's go to the next part where we are going to get the asynchronous request. All right, so right here void handle root, and here we'll need async web server request and point it to request. And here we do the same thing. We basically get the date and time, so I'll just write here RTC date time. We could do it in the same function on top, but I want to keep it separately in case anybody wants to use it separately for their project. And then basically the format here, I think I'm just going to copy paste it from the top. So just copy paste it, and here now since here it won't be dt anymore, it's going to be now, right? And all right, so this is how I've done it: day, month, year, hour, minute, second. And since we do not need to get this printed, okay, now we need to respond to the web request with the current time, so we need to send it in the form of string response. So here it's basically the HTML code, so HTML head, and inside the head I'm going to have a meta tag so that I can refresh the page after every 1 second so that the time updates. So I'll say refresh content, right? And let's move to the body, go to the next line of the response. So it's written as plus equal to, and then you can continue with the next line. So here I'm going to have a very basic HTML tag called h1, which is header, and then just write current time. Don't forget to put semicolons. So then you can keep on going, you can keep on adding more and more. You can just add more to the string, but that's going to just overload it. So it's always better that we kind of okay, here the string is here we need to add this as the date string, so plus close, yeah, because I am here concatenating two different strings, and then I want to save time, so I just close the body tag and close the HTML tag as well. Alright, so that's it, and then send the request. So request, send it if it is okay, send 200, and the file type is text HTML, and what we need to send is the response. So that's all that we need to really do. Now we are all set. There was a lot of code here. All we need to do is now upload the code. Excuse me. So now I know that this is a heavy dose of code. If you are not good at C programming, I recommend you to skip it and then just take the code from the description and upload it onto your microcontroller. Okay, so we need to define a few more confidence checks or for the RTC. We need to check if the RTC has lost confidence. So we're going to say if not RTC dot is date time valid. So here, like I've already mentioned, you need to check your device for the battery. Here I just type the what it is supposed to do in case if it is not able to start. Set the date time as the compiled data. So that's the first case. And the next one is if RTC is write protected, which means it cannot write new time onto the module. So we will get this error which is get is write protected. Okay, so if we get this error, I mean if we will check this just once when we run the code for the first time. So if it is write protected, then we'll say it was write protected but enabling it now. Okay, so that is what we are going to do. We will just say RTC dot set write protected. Okay, set write protected. It is set is write protected to false. So once we set this to false, we will be able to write new timings. And then the last case is check if it is actually running. So RTC dot get is running, and if it is running, okay, let's say if it is not running, so we will say serial dot print not actively running, which means this module was never used or has been it just out of the box, and it has never been uploaded with a code before, so it is not actively running. Now what do we do when this is the case? We will say that we will set running to true. So we'll just say RTC dot set is running to true. Then get the current date and time. We just check. Okay, so let's say RTC date time now equal to RTC dot get date time. Okay, and then we need to check if the compiled time is older than what it is presently, what is the present time. So let's check if okay time status. So if now is less than the compile time, that is compiled, I just say that serial dot print ln. We'll just say that RTC is older than compile time. And this is not what we want. So this case we will just say RTC dot set date time to the compile time, because we do not want to set it to something that is older. Then the other case is else if now is greater than the compile time. So this is something that is expected, and we want we want the timing to be greater, so we do not have to do anything in this case, but just for our understanding we will write here RTC is newer than compile time, and this is expected. So we do not do anything here. And else if, okay, I mean this is an impossible case, like else if now equal to the compile time, like when I'm actually testing this case, this is an impossible case. uh, there is no way that the current time and the compile time will be equal, but if we do get it, then we still accept it the way it is. Okay, I mean it, the code takes some time to compile it from the system to the microcontroller, so the present time and the compile time is never going to be equal. So let's say RTC is same as the compile time. Not possible, but it's fine. Okay, so ah, there you go. So now all the cases are done. So now let's compile this code. So after running it, okay, you'll see that the case which says RTC is newer than compile time, this is expected, and this is the current time. So if you want to see that, then here you go. You can actually check that the current time is 1654 and it shows the right time here, and it's being updated every single time. Now if you have not noticed, over here we have the, I'll just disable auto scroll here, and you'll see that we had the local IP being printed. You can copy this and paste it in a new Chrome tab. So you'll see that the current time, it will update after every 1 second. And please note that this particular time is it's initially fetched from the system, so that what it only means is that if you have your system time set to a particular timing at the beginning, so if this is the timing and if this is the time here, I mean when you upload the code, the timing over here will be different. Now you can see the system time is different from what my ESP32 is giving me out. Alright, but after a fresh re-upload, the current timing would change based on the system timing from where it is being uploaded. Okay, this is all about real-time data. So you can actually check the timing here. Now my backlit is off, so that it becomes, it is actually visible. So if you want it, you can keep the backlit on, you can mention it in your code. And so this is all for a real-time project. And for the other parts of from where in the next video segment we'll be covering other important parts of the ESP32, like I mentioned in the ultimate guide for the ESP32. We'll be using other complex sensors with the which will be interfaced with the ESP32, and having web servers or synchronous web servers for it. So there you have it. It's an ESP32 interfaced with the DS1302, displaying real time, and an LCD web server. The applications are endless, from smart home projects to industrial automation. So if you found this intriguing, and please do not forget to share, subscribe uh, for more simplified content. I'll catch you in the next one.